Okay, so I've just started recording. What the plan was today, I handed out this sheet about kinematics last lesson. There is a video here if you've never heard of kinematics, if you haven't done much physics or science before to sort of know what kinematics is. You don't have to watch it if you already have an idea of what kinematics is about, but if you have got no idea about what kinematics is about, it's probably worth watching it at a later point in time. Normally, no, we're not watching it now. We don't have time. You're not listening. Those people who come in, you're like 5 minutes late. You need one of them, grab one. So, short version. Normally about now, I would go back to that rates of change activity that we did where I'd walk back and forwards across the classroom and you would draw some graphs to show displacement, which is what we did last time and we talked about rates of change, and then I'd actually get you to draw graphs to show my speed. All right? And then from there, we would say, okay, speed is how fast I'm going, and I could be going fast in this direction, or I could be going fast in this direction. If we're talking about speed, we don't care which direction you're traveling in. All right? So we're going to have the words, instead of distance, displacement, instead of speed, velocity, and then acceleration is the same in both versions. But these include direction. So these include positives and negatives. And that's what we're going to talk about now. Unfortunately, due to our time constraints, we're not going to have a lot of time to build up a deeper understanding of kinematics. So I'm going to rely on perhaps your... you guys are 5 minutes late. You need one of these. Makes it really hard to teach with all the interruptions. Also makes it really hard to learn with all the interruptions. So, the short abbreviated version. I handed you a sheet of paper last time that had a summary of kinematics. What it's trying to tell you is when you have a displacement graph, okay, displacement tells you how far you are from a point. The displacement from a point, Tom, can be positive or negative. If you want to know about what the velocity is, or your speed with direction, then we can look at the gradient. So for this graph, this is a graph of a little remote control car. It's on the sheet that I gave you last lesson. Can you hold that up, Tom, so everyone can see what we're talking about? Do you have that sheet in front of you? It's talking about a little remote control car that's driving from a point. Short version, if the gradient is increasing, then we say the velocity is increasing. If the gradient is constant, so the parts of the graph that are linear, then the velocity is constant. So if they're talking about a constant velocity, it means that the velocity is a singular number, it's not changing. Gradient's decreasing, velocity's decreasing. Gradient's zero. It is a constant velocity, but more specifically, it's a zero velocity. If something has a zero velocity, we say it is at rest. So if you ever see a question where it says it is at rest, that means the velocity is zero. All right? And then same, this is an increasing velocity in the negative direction because it's getting steeper or it's getting more negative. Constant velocity in the negative direction, decreasing velocity in the negative direction, constant velocity in the negative direction. We can still be below the axis. That would mean I went back past the original point. So that's the speed version. What you really need to be doing, because we're doing this in our calculus unit, if we're given information about the acceleration and we want to find the velocity, we can integrate or find the antiderivative. If we know about the velocity and we want to find something about the acceleration, we can differentiate. So velocity is the rate of change of displacement. Acceleration is the rate of change of velocity. So we can just move between these three things using differentiation and anti-differentiation. And that's what we're going to look at right now. We're going to look at it as an example. We're going to go through this example because this is my speed lesson, and then you're going to have a go at one. So we've got a particle moves along a straight line. In year 11 methods, it's always a particle along a straight line or an object moving in a straight line. So we can pretty much ignore this. Doesn't mean it's linear, just means motion's going in one direction. All right? So that after t seconds, its position, S is commonly used for displacement, relative to a fixed point O, that's like our origin or our starting point, on a line is given by this. So we've got an equation that tells us our displacement is equal to t cubed minus 3t squared plus 2t. Okay. It's moving from a fixed point O on the line. When is the particle at O? Now, we've got to pick out some of the language in here. When, I'm going to do the bad thing where I write on the board again. Hopefully it doesn't stay too bad. When is the particle at O? When the question says when, what is it asking you to find out? It's asking us to find out what time is. All right? So if it's asking us to find the time, what variable are we going to need to find? T. Okay. This word here tells us we're finding t. All right? Is the particle at the origin? So this rule is the displacement from a fixed point O. So what would the displacement be if we were at the origin? What would the displacement be if we're at the starting point? 0. So this question, written in plain English that we need to interpret, it's actually saying find t when s equals 0. All right? So this first question is simple substitution. 0 equals t cubed minus 3t squared plus 2t. If it was in your test next week, how would you solve this? What am I talking about? Using your calculator. So if this is in a calculator part of the test, don't you dare try and factorise it and use the null factor law. There's no marks for that. This question on a calculator test will be, can you find the solutions, yes or no? And I know that you've got your calculator. I'm expecting you to use it. There's no bonus marks for doing it by hand. All right? So just bang that into your calculator and get your answer. Oops, pressed the wrong button there. So, solve, someone read out the equation to me. Yep. Does it make sense that we have 3 answers? Okay, so let's say this point's the origin, right? So what's happened to our particle? It's been moving away from the origin and then come back to it after 1 second and then moved away from the origin again and then come back to it after 2 seconds. Or it could have been started at the origin, pretend the calculator's the origin. It could have been I moved away from the origin and then back after a second and then continued in this direction and then back after 2 seconds. All right? If I did that one, forwards, then backwards, then forwards, if you think about what that looks like graphically, it's a cubic, isn't it? We went forwards, then backwards, then forwards again. And then we're at the origin at this point, this point, this point. Positive cubic, positive cubic. Our parts are starting to mesh together and match together. All right, that was A. Let's move on. Part B. What is its velocity and acceleration at these times? Okay, how do I find the velocity when my formula is for the displacement? Differentiate. All right, so let's find the velocity. So we're going to call this S. What do you think I might use for V? Oh, I told you the answer. What do you think I might use for velocity? V. V, excellent. So the velocity is the derivative of the displacement. So ds dt. I differentiate this. If I differentiate this, 3t squared minus 6t plus 2. And we want to know what is the velocity and the acceleration at these times, the answers for this. So let's say, okay, when I substitute in 0, I get 3 times 0 squared minus 6 times 0 plus 2. Hopefully you know that's 2. When I substitute in 1, 3 times 1 squared minus 6 times 1 plus 2. 3 minus 6 plus 2, negative 1. Velocity at 2 is 3 times 2 squared minus 6 times 2 plus 2. 4, 12, minus 12 plus 2. It's back to 2 again. All right, so we found out the velocity at all of these times. Have I finished the question, Jake? No, what do I have to do now? Okay, what letter are we going to use for acceleration, do you think? Probably A. And what A is going to be is the derivative of the velocity with respect to time. So we differentiate it again. 6t minus 6. And then the acceleration at 0, 6 times 0 minus 6, which equals minus 6. My acceleration at 1 is at 6 times 1 minus 6 equals 0. And the acceleration at 2, 6 times 2 minus 6 equals 6. So my speed is positive at the start. So if this was our origin, and we call that the positive direction, I speed off in this direction. Okay? After 1 second, my speed is negative. My speed's in this direction. My velocity is in this direction. After 2 seconds, my speed is back in that direction. It's back to positive again. At 0 seconds, at the beginning, my acceleration is minus 6. If my acceleration is minus 6, what am I doing? I'm not moving. More specifically, I can be moving, but I am slowing down. So if my acceleration is minus 6, that means I was moving forwards, but I'm slowing down. Okay? So if your acceleration's minus 6, you're slowing down. If your acceleration's 0, you're neither slowing down or speeding up. And if your acceleration's 6, you're speeding up. Cool. What is the average velocity during the first second? Okay. Velocity is the rate of change of displacement. Okay, so velocity is the rate that my displacement's changing. Like speed's the rate of change of your distance. So this is actually saying what is the average rate of change between t equals 0 and t equals 1. Average velocity is the average rate of change of displacement in the first second, so between 0 and 1. Who remembers how we find the average rate of change? We did this just before the holidays in that short unit, and then I said holiday homeworks to do those practice questions.
V take you over T.
Say that again.
V take you over T.
V take u over t. So if you know physics, V take u over t. What's V? Sorry? Final velocity. This will give me what does this give me? It gives displacement? No, I don't even think it gives displacement. It gives acceleration. Doesn't it give acceleration? Something like that. Can't remember. I can't remember either. I've forgotten those rules. No, we're not going to do that. Average rate of change. How do I find the average rate of change? We got something increasing, decreasing, going back again, and we want to know the average rate of change between 2 points in the first second. This was t equals 0, and it was back to the origin after 1 second. Oh, t. Do you have notes on the average rate of change? How do I find the average rate of change? Right, so y2 minus y1 divided by x2 minus x1. The average rate of change is just a gradient between 2 points. Are we using x and y though? Keep talking. We're not using velocity because the average velocity is the average rate of change of displacement. So we want to use S and T. So we want to work out what is the displacement at, and this is where you said initial and final, what is the displacement at the end minus what was the displacement at the start divided by what was the time at the end minus what was the time at the start. We know what these two were. The time at the end is 1 second, the time at the start is 0 seconds. What was the displacement at the start? 0, how do you know? When t equaled 0, where were we? We're at 0. When t equaled 1, where were we? We're still at 0. And what's 0 divided by 1? 0. What's our average velocity? 0. And we're going to assume it's meters per second. All right. If we think about what that graph is, this is where it was at 0 seconds. This is where it was at 1 second. What's the average gradient? Like it's a flat line, isn't it? Yeah. So if you want, you don't actually need to do any of that working out. You can just jump to the answer. But I did want to revisit the idea of average rate of change because that was before the holidays and we didn't get tested on it. So guess when you could get tested on it? In the test. or the exam. All right. Clarifying questions. No? Can I rub that out yet? Sorry? Is that, yeah, it is filming. Yep, yep. It is filming, isn't it? Yep. All right. Okay. So that's our first type of question. Our first type of question was when we differentiated to find values. Our second type of question is when we use the antiderivative to find our values. Okay, so we're going to anti-differentiate to find our values here. I just need to grab those wipes. Where did they go? Oh, there, thank you. Okay, have a read of the question. What information have we been given at the start? A particle moves in a straight line. It's always in a straight line in maths methods. The course doesn't go beyond straight lines. It starts from rest at the origin. It starts from rest. What does it mean that it's at rest? What zero? It's not moving, so what's zero? The velocity is zero. Does that mean the acceleration? No, it could be accelerating, but its velocity at that point is zero. So its velocity is zero when t equals zero. So this starts from rest is telling us that v equals zero when t equals zero. So it starts from rest, means that v equals zero when t equals zero. It starts at an origin O. What is that telling us? It starts at the origin O. So when t equals zero, what's the displacement? So when t equals zero, I kind of did that backwards, but you get the right idea. The displacement also equals zero. So this little sentence is actually a whole heap of information that we can apply specific numbers to when it's kinematics. So we have to be able to pick out that language and get the numbers from it. All right? And its acceleration, a meters per second squared, or a meters per second, at time t seconds, is given by that. All right, so this is our key information. Part A, find the velocity of the particle when t equals 3. Find velocity when t equals 3. How do we go from acceleration to velocity? We have to integrate. So we have to integrate, do the antiderivative of the acceleration formula. So we need to do the antiderivative of 4 minus t and we know and when t equals 0, v equals 0. So we're anti-differentiating at a point. If we anti-differentiate, we know how to do that. Add 1 to the power, divide by the new power. What do we also have to have when we anti-differentiate? Plus c, good. Okay, so we've anti-differentiated and we've got the point when t equals 0, v equals 0. What do you think I'm going to do next? Substitute them, why?
Because we're trying to find what v equals at when time is 3.
Okay, we're going to find out what v equals when time is 3. So why are we going to substitute these ones in first? To find out what c is. So before I can do this part, before I can substitute in t equals 3, I need to know what c is. So let's find out what c is. V equals 0 when t equals 0. So now that we've shown that c equals 0, we know that we don't need it. So my velocity formula is 4t minus t squared on 2. Don't need c anymore because c is 0. And now we're going to do the substituting of t equals 3. So the velocity at t equals 3, 4 times 3 minus 3 squared on 2, 12 minus 4.5 equals 8.5. No, it doesn't, 7.5. That is an exact value.
Yeah, we want to need
And you might need to do it in fractions if it doesn't work so nicely as a half. It's okay to give a 0.5. 0.5s are rounded off. It's not rounded off, sorry. It's exact because it's a terminating decimal. It's exactly 7.5. Or I could have done 15 halves. Either way. Okay, that's part A. B. Find the displacement from the origin when it next comes to rest. The displacement from the origin when it next comes to rest. What does that mean? Some key terms in there. What do we think comes to rest mean? Velocity equals 0. So this is saying, when is the velocity next equal to 0? When was it first equal to 0? At the start, at the origin, when we began. So, how can we find out when the velocity equals 0? We've got a formula that tells me the velocity. And I want to know when that equals 0. So I have to solve this equation. That one would be pretty quick to do by hand, but I want you to practice doing it with your calculator. So I can do it on my calculator. All right. So I've got t equals 0 or 8. So 8 seconds is the next time it's at rest. Agreed? All right, so we want to find the displacement when t equals 8. The displacement from O when it next comes to rest. Find the displacement when t equals 8. How do we find the displacement when I know what the velocity is? Integrate. Good. So, I know what the velocity is. I have to find the displacement. I'm going to integrate. So I want to find the integral of this equation with respect to t. And we know that s is equal to 0 when t equals 0. I can do it by hand. I can do it on the calculator. Who knows how to do the antiderivative on the calculator? Probably is in menu somewhere. So if I went menu, calculus, we've got derivatives, derivatives, derivatives. Get out of that. Did we have an integral? So it looks like this. I can ignore them. That comes up later. We're not doing that. Ignore them. Put your formula in here. 4t minus t to the power of 2 divided by 2. And we need to put what our variable is in at the end, dt. What this doesn't do, the calculator does not give me c. I have to put the plus c on myself. Now I'm going to find out what c is. How am I going to find out what c is? I'm going to substitute in this point that I know. And we get c equals 0. Therefore, my displacement formula is just 2t squared minus t cubed on 6. And we want to know displacement when t equals 8. So I need to substitute in 8. And I'm feeling lazy, so I'm going to use my calculator. 2 times 8 to the power of 2 minus 8 to the power of 3 divided by 6. So after 128.3 metres, its velocity will be 0 again. Now I'm going to stop there. There was 2 more parts to the question. This was my crash course in kinematics, right? What are some of the key things that you think you might like to take from this short crash course? Integrals, what about them? How to do them. Right, you have to remember how to do integrals. What else when you do integrals? There's a plus c on the end. How do we find plus c? Substitute in initial value. So what do I want you to take out of this? When we do integrals, we get a plus c, and when we have a plus c, we can often find that plus c by substituting in a point. All right? You can also use your calculator to do integrals. What else do you think I want you to take from this? The letters, what they mean. So S, V, and A. And that you can move between them using the skills we have already learnt about differentiation and anti-differentiation. So it's essentially all kinematics is differentiation, anti-differentiation, and substituting in points. One more key thing that I want you to try and take out of this.
Understand the key information.
Picking out the key information. Awesome. That is the one other thing. So things like at rest, velocity equals 0. At the origin, displacement equals 0. Initially, time equals 0. You have to kind of pick out those extra little bits of information in a question. All right? Now, you've been sitting pretty idle, listening to me. There are some practice questions, but that's not going to be our focus because we're also doing some catch-up. We're doing some revision. So what I'm going to get you to do before anything else is our Nearly There quiz. This is going to serve as some revision and some feedback before the test. So I want you to do this and hand it to me when you're done so I can mark it and give you some feedback. And then we can look at kinematics later. Don't work on your summary journal now. You can watch this video back later if you need. You can use your summary journal, you can use your calculator. Go.